So we're taking up the sixth type, Leibniz theorem we have to apply here. So as we know that u function has to be taken as what, one polynomial. Here the polynomial is x, a linear factor we have got, and b function has to be taken rest all. But the problem is here that in rest all term, if we have to find out, first we'll see the Leibniz formula. So here is the Leibniz formula. In this, if you observe carefully, u is there, vn is there. So we have to find out vn. So if I take x as u function, so u is x, and v as e power 2x into sine 3x cos 2x, then what happens? If I want to find out vn, do I have a direct formula for this? No, I don't have any direct formula for this, right? So how to resolve that? That is the question. So resolving this is very simple. What you have to do, cos sine 3x and cos 2x can be resolved into, it is in product form. We have discussed product. What you have to do, convert into convert into sum form, right? So how to do that? So y is equal to x e power 2x, then sine 3x and sine cos 2x. What I'll be doing, I'll be applying a formula for sine a cos b. The formula for sine a cos b, right? You might have studied. What is the formula for that? Sine a plus b plus sine a minus b, right? Into 1 by 2. So 1 by 2 into this thing. So same formula has to be applied here. So what will happen? Sine a is 3x plus b is 2x, right? You can observe over here 3x and 2x. So this is a and this part is b. Plus sine, so I'll remove this particular thing. Plus sine a minus b into 1 by 2 is there. So 1 by 2 you can take it outside, right? So I'll multiply here. Okay, we can take it outside. So simplified version of this will be y is equal to x into e power 2x into 1 by 2 into sine 5x plus sine x. So this is the formula we got. Now we can just multiply inside the e power 2x, because e power 2x has to be taken with this itself, right? So what will happen? Y is equal to x into, so 1 by 2 is there, 1 by 2 is there. So this both the things I'll multiply inside, right? So multiply inside. So 1 by 2 outside, multiply inside, x e power 2x into sine 5x plus x e power 2x into sine x. Now what is the problem here is that after multiplying, we have to find the nth derivative. So the nth derivative yn is equal to 1 by 2 outside and nth derivative of x into e power 2x sine 5x plus nth derivative of x into e power 2x into sine x. Now what is the problem here? Nth derivative of this and this, we have to apply Leibniz theorem separately for both, because both the things has been reduced into a product form, right? Where x is the u function, v is here e power 2x this thing, but here x is u, v is something else, e power 2x into sine x. So both the things we have to apply Leibniz theorem. So what will happen? So together we'll apply both the things. So 1 by 2 is sitting outside. Okay, so 1 by 2 is sitting outside. That has to be multiplied with summation of this both. So we'll see one more time what is the Leibniz theorem. So here you can observe the Leibniz theorem. In this particular theorem, till where we have to solve, or till where we have to do the differentiation part, it is based on u. So u is there. So let me just take from here u. Both the cases u is same. So u is equal to x. So what will be u1? u1 will be differentiation of x, which is 1, and u2 will be what? Differentiation of 1, which is 0. So that means what? This u2 I cannot take, because the entire term becomes what? 0. So till where I have to take? I have to take till here itself. That means till here. These two terms only has to be considered while applying what? Leibniz theorem. Simple concept, because u2 is 0 means this entire thing 0. Rest all will be automatically 0. Right. So till both the cases, because both the cases u is same. So till two terms only I have to calculate. So very simple concept. So we'll do together itself both the things. Now here in this particular case, Sine 5x is the e power 2x into sine 5x. What is the formula for that? Which formula you are going to apply? So for finding the nth derivative of this and this part, we are having the formula y is equal to e power ax into sine, both the cases sine only, ax plus b. This is the particular formula we are going to apply. Okay, fine. So here yn becomes what? That is the question. So yn for this particular thing will be square root of a square plus b square whole power n into e power ax sine n pi tan inverse, n into tan inverse b by a plus bx plus c. This is the formula. Okay, quite lengthy formula. This has to be applied here. So first we'll take this particular thing. So v is equal to, we'll consider what, e power 2x into sine 5x, right? For this we'll find out nth derivative vn, which is e power 2x. What is a value? Compare with the standard thing, a value is 2. So a is equal to 2. What is ax plus b? Ax plus b, here a value is what, 5. A is equal to 5. What is b value? B value is 0. Because here ax plus b, here sine 5x plus 0 you can consider, right? Now we can apply this formula. It will be square root of mistake. So both can be a, right? So it is bx plus c. Sorry, I have done one mistake here. It is bx plus c. Okay. So here the b value will be what, 5. C value will be 0. Okay, because a twice it cannot come, right? That's it. So a square, so this is 2 square plus b square in the sense 5 square into e power ax, which is 2x, into sine n into tan inverse of b by a. What is b by a? 5 by 2 plus bx plus c means 5x plus 0, so you can just write 5x. So what is 2 square plus 5 square value? 2 square plus 5 square is how much? We can directly write it as, or otherwise next step we'll write. So Vn is equal to 29. So square root of 29 power n, power n is there. Power n e power 2x sine n tan inverse b by a plus 5x. Okay, done. Now let us go for the next v value, which is e power 2x sine x. So what will happen there? So we will consider now e power 2x sine x. The only change is that b value will become 1, c values anyways is 0, a value will remain as it is, which is 2. So again you have to apply the same formula. So vn becomes square root of a square means 2 square plus 1 square whole power n into e power 2x sine n pi, n tan inverse b by a, so 1 by 2 plus bx plus c, that means x plus 0 I can just write x. So here what happens, 2 square plus 1 is what, 5, so it will become square root of 5. So we can write it as bn is equal to square root of 5 power n into e power 2x sine n tan inverse of 1 by 2 plus x. Now we have just found out Vn, right? We have to find Vn minus 1 also as per the formula. Now how to find Vn minus 1? The thing is that only in place of you substitute what, n minus 1. That's it. So wherever you see n, just substitute n minus 1. So what happens? The first term Vn minus 1 will become here square root of 29 power n minus 1 e power 2x sine n minus 1 into tan inverse of 5 by 2 plus 5x. Simple. So here Vn minus 1 will become square root of 5 power n minus 1 e power 2x sine n minus 1 into tan inverse of 1 by 2 plus x. Yn becomes what? Yn is nothing but equal to 1 by 2 into u value for the first function x into square root of Vn 29 power n into e power 2x sine n tan inverse of 5 by 2 plus 5x. NC1. What is NC1 value? Always remember it is n itself. So n into u1 value we know it is 1 into vn minus 1 will be close the bracket. Now here 1 by 2 has to be multiplied with one more term was there, plus again the same concept, u into. So what I'll do, instead of writing 1 by 2 separately, 1 by 2 I'll just multiply with both, right? So you can just write here 1 by 2 this thing. Here one more 1 by 2 will come. So 1 by 2 into, again the same thing, x is there. Now NC1 value we know it is n into u1 value will remain same as this thing itself into vn minus 1. It will be answer.